Welcome back to Pure Science Education, and I bring to you paper 2 predicted questions for rate of reaction topic only. As this is predicted questions, please do revise all content. Anything can be asked in the exam. I'm going to show you two different ways of calculating rates, one by graphs and second by using the formula. In graphs, there are two different types of graph they can ask you to calculate a reaction. The first one is where they can ask you a specific time or volume you need to calculate it at. So in the first graph I'll show you, I've calculated rate at 2 seconds. So I draw my line going up at 2, and you'll see I've drawn my tangent touching at 2 as well. Now, tangent is this line that you draw across the curved part of the graph. And what you then need to do is work out the y-axis. If you look here, I've done the differences from 4 and 5.5 give me 1.5, and then the bottom I've done the same, and it's 2. And then what you've done is the formula is y divided by x. 1.5 divided by 2 gives you 0.75, and then you divide the units, which is cm cubed divided by second. So this is at a specific time. In the second graph, I've shown you how to calculate at different points of the graph. So A is the steeper part of the graph compared to the B where it's plateauing off or the reactions stopping as the reactants may have used up. To do A, you're going to draw a tangent at A, again touching the curvy part, and you're going to do the same thing. You're going to do your y divided by x and then work out the differences, and the same here, y divided by x. That will give you the rates of reaction at two different points in the graph. In addition to that, they can ask you to use the formula, and if that's the case, then the formula is rate of reaction is amount of reactant used divided by time it takes for the reactants to be used, or it could be the rate a reaction is equal to the amount of product that's been found over a given time. So these are all the ways you can calculate rate in an exam. This is an experiment that can be used for different things, surface area, loss in mass. It can be used for different scenarios for rates of reaction. So I'm going to show you how to do this particular one. So I've started with marble chips, which is scientifically known as calcium carbonate. I've reacted with hydrochloric acid, and it makes calcium chloride, water, and carbon dioxide gas. So when they say loss in mass, they can ask you in the exam why the mass has been lost in diagram 1, which is this one here. And because carbon dioxide is a gas, you can say it's escaped to the atmosphere despite the cotton wool being there. They can ask you for improvement to this experiment, and the improvement will be that you'll use a gas syringe, which is diagram 2, so none of the gas can escape, and also you can accurately measure the exact volume of gas that's been produced. This experiment can also be used for surface area for rates of reaction, so you can use a powdered marble chips, or you could use larger size marble chips, and then time how long it takes for them to break down or dissolve, and also the volume of gas being produced. So it could be volume of gas you're measuring, or it could be the time it takes for the marble chips to break down. Here's another required practical, this time looking at effects of temperature. You're going to react sodium thiosulfate with hydrochloric acid. Do not heat it above 60 degrees as harmful gases will be released. And you start off with sodium thiosulfate 50 cm cube in a conical flask. You then add your 10 mils of hydrochloric acid, which has been warmed up to different temperatures, and you're going to put it on a X with a paper cross on it. And what you do, you time how long it takes for that cross to disappear and a solution that's formed that you can't see through. The question for the exam will be, why can you not see through the solution? And the answer is the solid sulfur precipitate has been formed. Collision theory, the rate factors affecting rates of reaction can be surface area, temperature, concentration and pressure, and catalyst. So if you're looking at surface area, if you have a large surface area on the cube, you can only react stuff on the outer sides of it. And if it's large surface area, you can interact everywhere. Increasing temperature gives the particle more energy, they vibrate more, they collide with more energy, so more successful collisions. Concentration and pressure is the same. If you've got lots of concentrated particles, then a faster rate of reaction. more collisions happening, faster rate of reaction. And in a graph, you have two graphs that you can see here. The first one in black is the activation energy is higher without a catalyst, and if the purple one, if I add my catalyst, it reduces the activation energy. Any of these combination of questions can come up. And generically, increasing any of these factors give particles more energy to either vibrate or move, which then leads to more bombardment, more successful frequent collisions happening as well. The Shetty's principle is something that happens in a dynamic equilibrium situation where it counteracts the change. So if you go a side that has got less number of moles, low temperature or low pressure, it will favor that side to make sure both sides are equal. So for example, if I have 2A plus 3B and then I have 2C plus 1D, then this side I've got 5 moles in comparison to this side, so it will favor the forward reaction in comparison to the backwards in order to counteract the change. I hope this was useful. Don't forget to watch other videos. All the best with the exam.